All right, first thing you're supposed to check, again, if you have your test tomorrow, turn in the 8-7 packet, more vectors worksheet in this review. If you can make a triangle out of the 3 lengths, that would be determined by whether the smaller 2 added is more than the third. I don't really need you to write anything down, just make sure you checked if it's possible to have a triangle. 7 plus 12 is bigger than 13, so you can make a triangle. So then you start to check what kind it is. You start with the biggest number. Come on. And then you square it, and then you square the other 2 and add them. 13 squared is 169. This would be 49 plus 144. We calculate what that was? 193. Awesome. All right, thank you. And that's less, 169 is less than 193, so that would make this an acute triangle. Okay. Number 2, when you add 9 and 6, you get 15, so there's no possible triangle. No triangle possible. Why? Because 9 plus 6 is not bigger than 15. And then you don't bother with squaring them or anything because that's determining what kind it is. And there isn't one. 9 and 12 would add up to something bigger than 18, so we can go forward with this one. So you say 18 squared, you compare it to 9 squared plus 12 squared. 18 squared is 324, and what's that? 81 plus 225, yep. And that is an obtuse triangle because the longest side squared is greater than the sum of the smaller 2 sides squared, so it'd be obtuse. If you get it to be equal, which is the next one, because you should be getting 100 equals 100, that means you got a right triangle. Okay. Number 5, you're finding the missing side. This would be your Pythagorean theorem. Not special right triangles, Pythagorean theorem. This is a leg, the side across from the right angle. Note that that's your hypotenuse, so these are legs. Leg squared plus leg squared, x squared plus 6 squared equals 10 squared. You will need to subtract 36 from 100, or from both sides, what technically is correct. X squared equals 64. You would then take the square root of 64 to find out that x, the missing side, is 8 feet. Need a label on it. The next one is missing its hypotenuse, side opposite the right angle. So that means we have x squared. We're going to say the longest side, the hypotenuse squared, equals 9 squared plus 12 squared. We'll go ahead and find out that 9 squared plus 12 squared is 225. Take the square root, and we get 15 inches for the length of the hypotenuse. Isn't that 225? Oh, okay. 7, you're missing a leg. The hypotenuse is given. So we take leg squared plus leg squared equals hypotenuse squared. So this is x squared plus 16 equals 25. Subtract 16 from both sides, you get x squared is 9. Take the square root, and we get 3 yards. Okay, I'm going quickly through these. This is something we've done really a lot of times. Okay, 8. These are the harder ones. Special right triangles, your 45, 45, 90 pattern is in your ISN. You will be able to look at that. The legs are n and n. The hypotenuse is n times the square root of 2. And then you have a bunch of rules written down for you. This is the hypotenuse with no square root of 2 on it. Therefore, you are going to divide by 2, thank you, and put the square root of 2 on it to get the legs. Now, you can simplify that to 5 square roots of 2. So both x and y are 5 times the square root of 2. The second one is giving you a leg in the pattern. The 2 legs are equal, so that means y would be the square root of 2. And the hypotenuse, if you're given a leg, you're supposed to multiply the leg by the square root of 2 to get your hypotenuse. So what happens when you do square root of 2 times square root of 2? You get the square root of 4, which equals 2. Okay. All right, anybody need this still? All right, going on. 10. This one's giving you the hypotenuse with a square root of 2. So the rule, it says right in your ISN to take off the square root of 2, and that would be the length of the legs. So they'd be 8 apiece. Now in 11, we're at the 30, 60, 90 special right triangle. The pattern on that one is the short leg is n. The long leg is n times the square root of 3, and the hypotenuse is 2 times n. This is your hypotenuse. So the rule says in the list, take your hypotenuse and divide it by 2 to get the short leg. So 8 divided by 2 would give you n, which would be, of course, 4. Then to get the long leg, you multiply that short leg by the square root of 3 for 4 root 3 for m. All right, number 12, 30, 60, 90. This is the short leg. If you start with the short leg, you multiply it by 2 to get the hypotenuse. So 2 times 2 would be 4 for A. And to get the long leg, if you know the short leg, you multiply the short leg by the square root of 3. So this is just 2 times the square root of 3. Okay, that's your long leg hypotenuse. Okay, here we've got the hypotenuse, we got the long leg, and the short leg. This one gives you the the long leg with a square root of 3 on it. So the rule was take off the square root of 3, and n would be, the short leg would be 6. You take the short leg and multiply it by 2 to get the hypotenuse, so it would be 12. Okay. All right. 14. Now this is a gross one. You've got a hypotenuse with 4 square roots of 13, the square root of 3 over 3 on it. To get go from the hypotenuse back to the short leg, it says on your thing to divide the hypotenuse by 2. Well, if you took half of this, it would divide by 2, and you would cancel out and divide 4 by 2, and the answer would be 2 root 3 over 2. Now, don't write that. I don't want you writing that on there. I'm just trying to show you how I got it. Half of 2 square roots of 3 over 3 would be 2 square roots of 3 over 3. That's the answer for the short leg. All I was showing you is taking half of that only divides the 4 by the 2. Okay? All right, now, to get the long leg, the rule is, it says it right in the ISN, to multiply the short leg, 2 root 3 over 3, by the square root of 3. You could actually type that on your calculator, and it will do it. I'll show you how it's going to get the exact answer. Square root of 3 times square root of 3 would be square root of 9. What is the square root of 9? It is 3. So that's 2 times 3 over 3. And that cancels out 3's, and you end up with just 2. So x was just 2, y was 2 root 3 over 3. That's a pretty hard one right there. But it's doable with the rules that you've been given. All right, this is the long leg on 15 with no square root of 3 on it. In your ISN, it says, if you have the long leg with no square root of 3, you will divide it by 3 to get the short leg and put on a square root of 3. 9 divided by 3 is 3. So this is going to be 3 square roots of 3. Y equals 3 root 3. To get the hypotenuse, then, you multiply the short leg by 2. 2 times 3 root 3 would be 6 root 3. Okay. 16, now we're to the right triangle trig that you guys were doing very well with. What I think I want to do here is I'm going to set up, and that's it. You guys need to check if your calculation's right, and except I'll talk about ones that we got to go fast through here. Okay, and this was probably our strongest quiz was on this. All right, and because I want to get to some of the harder problems. So if I'm going from angle Z, this would be the opposite leg. This would be the hypotenuse because it's across from the 90. So the sine of Z, which is opposite over hypotenuse, better know that, would be 24 over 25. And that's all you do. You write the fraction. If it's reducible, you reduce it. Over here, if you're coming from the angle Z and you want the cosine, this would be your adjacent leg. This would be your hypotenuse. Cosine is adjacent over hypotenuse, so that's 36 over 45. You can divide both of those by 9. So that's going to be 4/5 when it's reduced. 18 is also just a ratio. You're coming from angle C. You want to do the tangent, so you're talking about the opposite and the adjacent. And that would be 28 over 21. Both of those are divisible by 7, so we reduce to 4/3. Okay, now this is just pushing the calculator. You would type in cosine 48. Everybody type it. I got to talk to you about muscle memory. I'm supposed to just type cosine 48. That's all it said to do. So I write 0.669. And now I'm going to tell you what I mean by muscle memory. When you're doing math in the class and you're just sitting there and you never open your calculator, you are losing an opportunity for your body to muscle memory. You build the muscle memory by practicing the calculations, and it helps you remember, and you will do better on your tests and quizzes. If you sit there and don't do it, then normally that will affect your grade. So it's not a spectator sport. You should be checking if you're going to get the same answers as me. 0.423. And then the practice also creates fluency. More practice makes you better. Bye. Okay, no questions on these, right? All you were supposed to do is write what's the nearest thousandth? That means 3 decimal places. That's why I wrote these. You should know that 3 decimal places is to the thousand. 21, find the missing angle. Now we're just hitting second tan to get the angle alone. So you'll be typing second tangent of the decimal that's given here. Second tangent, 0.3, was it, what's the next numbers? 549, thank you. All right, so 19.5 degrees is to the nearest tenth. Okay, and when you type second sine for the next one, second sine 0.6548. That is 40.9 degrees. If you haven't typed anything yet today, you don't even know if your calculator's in the right mode or if it's working properly. Okay, if you're not getting 40.9 degrees, you should be checking the mode and make sure it's in degrees. Okay, now this is, again, the section we did really well with was setting up, coming from this angle. This would be your adjacent leg. This would be the hypotenuse because it's opposite the right angle. This would be the cosine then. Cosine of 56 equals x over 18. You calculate 18 cosine 56, and that's 10.1. So to the nearest tenth, x is 10.1 units. And I'm not going to take off if you don't write a U because these aren't labeled. We'll just do the numbers. What's the trig function for number 24, please? The hypotenuse is blank, so what do you got to use? Tangent. Okay, thank you. Tangent. This is opposite, this is adjacent. The hypotenuse is left out, then you can't use sine or cosine. X over 13, you calculate 13 tan 52. I lost my pen, just a minute. My electronic pen. 13 tan 52, we should be getting 16.6. Okay, number 25, this is finding an angle. That's going to be the tangent. So tangent of x is 13 over 22. You're going to calculate second tan, and then you're going to put in the 13 divided by 22. And that's 30.6 degrees. You need degrees on those. 26, you got the angle 51 smushed between the hypotenuse and the adjacent leg. Adjacent and hypotenuse is your cosine function. Cosine 51 equals x over 13. So calculate 13 cosine 51. Got 8.2. All right, 27, what trig function will we use? Anyone? 27, tangent again. Tan x equals 6 over 23. I'm just gonna go on. And the 28, I think a lot of you, how many of you are ahead of me? Okay, this would be your cosine for number 28. Cosine x equals 22 over 23. Again, I'm going to post the answers on Google Classroom and, yeah, just the Google Classroom. Please go there. If you have not signed up yet, you should. Can you guys, does somebody want to tell me what 27 came out to, just so I can write these answers down quick and I'll have it recorded? 10.6? Ooh, 14.6, is that good? What about 28? 17 what? Even, yes, that's right. It rounded up to the nearest degree. Okay, 29, we should have sine 30 is 17 over x. Okay, now this one I would be very careful because this is not multiply because x is on the bottom, guys. So make sure you did number 29 right if you're ahead. You would have x times the sine of 30 equals 17. And then you would do divide by sine 30. And you should get 34. And 30 is the cosine. Cosine 38 equals x over 12. Just calculate 12 cosine 38. What'd you get for 30 if you already did it? Anybody else get 9.5? Yes? Okay. All right. 31, we should be doing tangent again. Tan 16 equals 15 over x. You're going to have to be careful about your calculation because x times the tangent of 16 equals 15. You got to divide. Okay, so 15 divided by the tangent of 16 is 52.3 degrees. Okay, and 32, this should be the sine. Okay, sine of x, the angle is 35 over 56. Take the second sine of 35 divided by 56. 38.7 degrees. Okay. 33, opposite over hypotenuse, it's another sine. Sine x equals 33 over 45. And 34 would be the tangent. I'm just setting those up. You should know how to calculate them, right? Second sine 33 over 45, and this one second tangent. Someone tell me what 33's angle measure is, please. So I don't have to calculate it, and thank you very much. And what's the angle for 34? 20 what? You agree? You got the same thing? Yes? Okay. I just want to make sure we're all getting the same thing because somebody could make a mistake. Thank you. All right, 35, gardening. Sophia wants to buy a flower bed. All right, this is already drawn out for us, so we're going to figure out the angles that the fences make with the border. Okay, you know there's a right angle in the corner of those two fences, and we want to find angle X, so I'm going to say opposite over adjacent. So I'm going to do the tangent of X is 6 over 3, and then go find that one angle, second tan, 6 divided by 3. But when you try to find angle Y, what's going to happen to your ratio? It won't be 6 over 3. 63.4 degrees for X. It would be tan of Y now, and then everything switches on you, because if you're coming from Y, then the 3 is opposite, and the 6 is adjacent. So if you're going to do tan of Y, you have to do that's 3 over 6. So you hit second tan, 3 divided by 6. And it wouldn't matter if you decided to reduce that fraction, it would give you the 26.6 degrees. Now, 26.6 degrees does make sense, because if you added it to the 63.4, you would get 90, which was what was left for those angles. Okay, Tom delivers papers. Okay, when he throws the paper out of his car window, it's 4 feet up in the ground, his little arm coming out of there. And this angle is the angle of depression from the window to the paper. That would be equivalent to this angle. So it's saying, what angle is he throwing the paper at? So let's put an X right there. We got a tangent then. So we got tangent of X is 4 over 15. Second tangent, 4/15. You know that if you play any sports or anything and you throw balls or you throw something or you're always thinking angles. You don't realize it, but you're actually doing angles all the time. When you're just doing stuff like shooting a basket, you need to know about how to project it so that it's going to go in. And that's about angles. There's so much geometry everywhere, and you don't even realize your body is estimating things to do it right. But it's your brain. Okay, let's do one where we got to draw the picture. If you were going to make a cell phone tower for me, what would you use to represent it? Would you put something laying on the ground? That's not going to be too good if your cell phone tower is laying on the ground. So what would you do to represent it? Yeah, draw something great, vertical. Okay, so I'm just going to make that be my tower. Okay, so we got a cell phone tower across from Jen's house. Jen walks 50 feet from the tower. She went over and stood there by the tower, and then she walked 50 feet away. So that should be on the ground. Jen doesn't walk in the air. She's not special. So she just walks over 50 feet. And she finds standing there, since she brought her protractor with her, that the angle of elevation to the top of the tower, do you understand what I'm saying? She noticed the angle. Okay, well, she had to measure it. You know, she stuck that up to her eyes. But hold on, it says Jen's eyes are 5 feet off the ground. Well, that means that this was Jen's head, and the ground was actually down here. Make 10. So that's 5. Okay, well, what are we going to be able to get off this? Oh, then the angle of elevation, the opening up angle from her eyeballs right here, is 60 degrees. So that's opening up towards looking up at the tower. How we're going to figure out something from this. We got a little right triangle here, so we can do opposite. We can find that height, but that's not going to be the whole tower, right? So what will we do at the end to answer how tall the tower is? Add on, yeah, we'll have to add on 5. So using our right triangle trig, we'll find X, and then we'll add on 5. So opposite adjacent is going to give you the tangent, bless you. Tangent X is X over 50. Tangent of 60, excuse me. So X is 50 times the tangent of 60. 50 tan 60. And I have a whopping 86.6 feet. But that's not the answer because X isn't the full length of the tower. So we add on 5 and we say the tower is, 91.6 feet. And it had to go to the nearest tenth. So that's it. Okay, 36, write component form of the vector. To do component form, you need to know where the vector ends and begins. A, the initial point, 1, 2, 3, 4, 5, 2. And the terminal point, B, at -1, -3. What you do is you subtract the B from the A, or other way around. You're going to start with B because that's your x2, y2. And the rule is you subtract. You do x2 minus x1 and y2 minus y1 to find your component form. All right, so we need to go down here and do -1 minus 5 and -3 minus 2. And simplify that, and the component form would be -6, -5. Okay, 40. If you're given these 2 points, find the component form of ST. It says ST, which T means is your second point. Your first point is the S. You want to subtract. So we're going to do -10 minus 2 and 7 minus -6. On that quiz, some of you didn't subtract. Some of you added, or you went in the wrong order when you subtracted. So please be careful about how you do it. The second letter in the vector name tells you what you have to start with to do the subtracting. Okay, so -12, 13 is the component form. Okay, 42, this looks like it's just a Pythagorean problem from the book. So x squared to the hypotenuse would equal 2 squared plus 8 squared. That's 4/68. You take the square root of 68. I don't know what that is, about 8.2. Someone check. Square root of 68. So I'd have, if I went to the 10th, it'd have to be 8.2. Okay. Oh, and it's in feet. Now, this one's kind of gross. I can take it in radical form, or I could let you do it with trig and give me decimal form. It doesn't matter to me. But if this is a 45, 45, 90, we could use the fact that this is a hypotenuse with no square root of 2 on it, so this leg would be 5√2. That's the exact answer. It's actually faster to do it using your special right triangle patterns. I wouldn't take off, though, if you did sine opposite over hypotenuse and you told me that it was, I'm just going to type this in and write down the decimal. If you gave me the decimal of 7.1, is that right? I don't know why I don't remember that. 5√2, 7.1? I would be fine with that. Here you could do, now that you know that, you could do opposite over adjacent and do the tangent of 30. Otherwise, if you're going to go to this special right triangle, this would be the short leg. To get the long leg, you would multiply by the square root of 3, and that would be 5 times the square root of 6. If you do it with trig, and you get me a 5, let's see, 5 square root of 6, you'll have a rounded answer of 12.2. I don't remember these being the answers earlier. Oh, I know what I did. I wrote 5. How did I get 5? It's supposed to be a 4. I wish you would have stopped me. I'm like, wait a minute. I know something's wrong here. This is supposed to be 4√2. Yeah, and then this would be 4√6. Sorry about that. So this isn't 7 point. I think it's 6.8 or something like that. Let me try. It should be 4√2. Not half of 8 times the square root of 2 is the short leg, or the legs. This one would be 4√2 times the square root of 3, which would be 4√6. I'm going to try that again. 4√2. If you did the trig, guys, it would be, I knew something was wrong, 5.7. And y would be 4√6 or if you do it on the calculator with trig, you're going to have 4 square roots of 6. You're going to be typing it differently, but you'll get 9.8. All right, 10, magnitude and direction. Now, magnitude, you got to find the component form. I mean, that's the best way to go about it. And then you're going to square and add. So find the component form first of the vector r to s, negative 2 minus 1, and 3 minus 0. That will give you negative 3, 3 for the component form. Now take those values and do the magnitude, which was always the square root of 3 squared plus 3 squared. And you don't even have to use the negatives, because you're going to square them anyway. That's 9 plus 9, so you get the square root of 18. Now, if you wrote exact radical form, that would be 3 root 2. I'm going to take the decimal. Square root of 18 is approximately 4.2. Okay. Sounds very reasonable. Yep. Or about 4.2. Then it says to do the direction. Now, the direction is the inverse tangent of the change in y over the change in x. Your change in y is the second part of that component form. The change in x is the first. So you can do 3 over negative 3, but that'll give you a negative angle on the calc. And you want to make sure you write down the positive angle. And I don't really want to get into why that gives you a negative angle, but it is 45 degrees. That would be your direction. I didn't plot it, so I'm not going into south of the east or north, south of west, etc. Anna's watching a space shuttle launch 6 miles from Cape Canaveral, Florida. When the angle of elevation and reviewing point is 80 degrees, how high is the shuttle? Okay, so I'm going to draw a little picture. You're somebody standing there watching it, and you're 6 miles from where it takes off. The shuttle would have gone up in the air. We're going to try to find how high up it is. Said her angle of elevation was 80 degrees. So she's looking up at an 80-degree angle to the top of the shuttle up in the air. Now, this would be opposite over adjacent. So it's going to be the tangent of 80 equals x over 6. And then we're going to answer, our answer will be in miles. So find out what 6 times the tangent of 80 is. 34? Oh, that's way up there then. 34 miles. 34 miles up. How could you see 34 miles up? Wow. It's incredible. 17, you're whale watching and you're looking, Isaac's looking through binoculars on a whale watching trip when he notices a sea otter in the distance. If he's 20 feet above sea level in a boat, so he's up in the boat and he's looking out with his binoculars, and in the water he sees some sea otter. Whatever, I don't know, some otter, sea otter. Okay, it says if his distance is 20 feet above, that's 20. And he's, let's see, and the angle of depression, that's like a little imaginary horizontal line coming off his eyeballs. It's looking down at the sea otter from here. That's 30 degrees. But we could put that 30 also down here by the otter. My sea otter. Ooh. All right, whatever. How far away from the boat is the otter? Oh, so that would be down here on the ground. That makes sense. How far is the otter from the boat? He's in the water. Opposite over adjacent. We got tangent again. Tangent of 30 is 20 over x. So don't forget, we got to divide on this one. X times the tangent of 30 equals 20. So x is going to be 20 divided by the tangent of 30. Okay, yep, 34.6 watts. That would be in feet. That's not very far away, little otter. Okay, component form we already went over. I think we could skip that. I will continue recording After you guys leave, you may watch it on Google Classroom or YouTube, Heimer Time, if you need to. If you don't, we'll just check our answers really fast tomorrow, but we got to start our test pretty quick. Yes. Okay, so we got 34.6 feet for that one. Now let's go to 3. Write the component form, which we did already, but again, how to do that. Find each point for 1 would be where C is. -2 is where B is. Now, the end of the vector is where, that's your x2, y2. x1, y1 would be where B is. You're going to subtract 4 minus the x1, -2, and the y2, 1 minus the y1, -2. 1 minus -2, simplify to get 6, 3. That's your component form. 24 says a plane is going east at 425 miles an hour, east, and the wind is blowing north at 35 miles an hour. Find the magnitude of the resultant velocity of the plane. Leave answers in simplified radical with a label. Well, we'll see if we want to do a simplified radical. I'm not going to force that on you. We would need to do the hypotenuse, so that's going to be like x, so it's x squared equals 35 squared plus 425 squared. So I'll go second. Excuse me. 35 squared plus 425 squared. That gives us a large number. We need to take the square root of that. So I'm going to do that right now. Second square root of that answer. Good night. Have a good one. Got 426.4 feet. Oh, nope, that's miles per hour. It's got to have the same label as those vectors, and I was corrected, so I forgot that's in miles per hour. And no, you do not need simplified radical form. The label, definitely, miles per hour. 25, I don't know how we jumped to 35, but anyway, describe each vector using ordered pair notation. This is where you want to find your y value, so drop from the end of the array of the vector and down to the x-axis. X would be your horizontal number, y would be your vertical number. You're trying to find x comma y, which is the component form. So we're going to do adjacent over hypotenuse. This would be the adjacent leg. This would be the opposite leg to the angle. That's 30 degrees. Adjacent over hypotenuse is your cosine. So we do cosine 30 equals x over 90. So we'll calculate 90 times the cosine of 30 to get x. And to find y, we'll do the sine of 30 equals y over 90. And we'll calculate 90 sine 30 to get y. Okay, so grab calc 90 cosine 30. And 90 sine 30. And I got 77.9 and 45. That does not seem to go together. Oh, those are lengths. Duh. Just thought that reminded me of angle measures. So back to the calculator. I got 77.9 for the x value and 45 for the y value. Now we have to think about what quadrant we're in, but we are in quadrant 1, so both of these are positive. So that's the final answer. 36, describe each vector again. We're going to go from the tip of the vector up to the x-axis. This will be y, this will be x. We're still going, and that 45 degrees is not even inside this triangle. So I'm going to say, well, since this whole corner is 90, 90 minus 45 would give me another 45 right there. Okay, so I'm going to stick with using things by the x-axis. So I have adjacent and hypotenuse. Cosine 45 equals x over 25, and sine 45 equals y over 25. 25 cosine 45. And if you think about it, since it's a 45, 45, 90 triangle, these answers should be the same. 25 sine 45, because the legs are the same in a 45, 45, 90. And we do, 17.7. Now we are down in quadrant 3. So this would have a negative value for x and for y. So we got to put the sign of a negative on both of those. 37, same idea, except this time going up to the positive x-axis. This will be x, this will be y. Same process. So cosine 60 equals x over 18. Sine 60 equals y over 18. Calculate 18 cosine 60 to get x and 18 sine 60 to get y. 18 cosine 60. Hit enter. I'm going to type both of them at the same time. 18 sine 60. And I got 9 and 15.6. So 9 and 15.6. And then I want to think about the fact that I'm in quadrant 4. X would be positive, but y would be down, so it's negative 15.6. Find the magnitude with label and direction of each vector. We're going to find the magnitude m, which is the hypotenuse of a right triangle. So m squared is going to equal 60 squared plus 70 squared. Actually, in our ISM, we said the magnitude is the square root of the change in x squared plus the change in y squared, which is what this 60 and 70 are. I don't care what order you do it, same difference. So let's get on that calculator and just type it in. Second, x square root, 60 squared plus 70 squared, or vice versa. Again, it doesn't really matter what order because we're adding. It matters when you're subtracting what order you do things. And we will find that that's 92.2. So I got a magnitude is 92.2, so we would need to label that 92.2 miles per hour. Don't forget the label. It will count off on the test tomorrow if you do not label it. To find the angle, it makes with the x-axis right there. That's theta. Theta is equal to the inverse tangent of 60 over 70. You always do change in y on top, change in x on the bottom for the tangent. That's opposite over adjacent. Inverse tangent of that will give me my angle. Second tan, 60 divided by 70. I got 40.6 degrees. And that is to the north of the east. North of east. 39, similar problem. Do our magnitude. Magnitude is equal to the square root of 9 squared plus 5 squared. I'll grab my calculator, do the square root of. I obviously didn't type something right, but or write it right. 9 squared plus 5 squared. Do it in the calculator correctly, and then I'll fix that in a minute. 10.3. So the magnitude is 10.3 meters. And then we got to find the angle by doing second tangent of 5 divided by 9. It has to be 5 over 9 because that's opposite adjacent for the tangent. Change in y over change in x. Second tan 5 divided by 9 will give us, come on, doesn't want to work for me here. There we go. 29.1 degrees. So it'll be 29.1 degrees, and this is opening from the west towards the south. So it's that many degrees, 29.1 degrees south of the west. 40, more of these. The magnitude will be the square root of 4 squared plus 3 squared. That gives you the square root of 25, so the magnitude is 5. So it's 5 meters per second. Find the angle, second tangent of the change in your y, which would be 3, over change in x, 4. And that's going to be 36.9 degrees. And that's opening towards the south from the east. So it is 36.9 degrees south of the east. Okay, 41, the last problem. An archaeological team is excavating artifacts from a sunken merchant vessel on the ocean floor. To assist the team, a robotic probe is used remotely. The probe travels approximately 3,600 meters at an angle of depression of 58.2 degrees. That's what this is. And the probe has gone the 3,600 meters. Now, it says down to the sunken vessel on the ocean floor. The figure shows a representation of the team's ship and the probe. How many meters below the surface of the ocean will the probe be when it reaches the ocean floor? Okay, justify your answer and give to the nearest 100 meters. All right, we're going to drop a perpendicular down from here to the ocean floor. That's what we want to find. We have created a right triangle. The probe, that's 58.2 degrees, can also be written down here by the probe because of alternate interior angles are congruent. Then we can use right triangle trig in order to solve for x. We know this 3600, and it actually looks kind of weird, like where it's written right here. It's right on this hypotenuse, if you will. So that's going to be opposite over hypotenuse, which will be the sine. We will use the trig, and do sine of 58.2 is equal to x over 3600. We will calculate by multiplying 3600 times the sine of 58.2. That will give us 3059.6. It said to the nearest 100 meters, which would be 3,100 then, meters. And that would be the depth. Now it said to justify your answer. This was showing this work, showing this drawing on the diagram. We used right triangle trig to solve. Now I have posted these answers as well, which were provided by another teacher. They should match my answers. And I just wanted to visually see what was written here for 41. Okay, so we may have written a little bit more of a description and justifying it. This is the answer that we got, and this is the equation that we wrote, which supports the work. You need to use sine since you know the hypotenuse and are trying to find the side opposite the angle. I will take the information that you draw on the diagram as an explanation. And I think that's enough review, and I hope you're ready for your test tomorrow and that everybody gets a great grade. Looking forward to good ones. Have a nice evening. I know how to stop this. I found it.